have to preface this, Kev, because CAN gets thrown around and people are like, oh, I know what that is, but I think most people don't know what it is, And if I were, of course, it's controller area network, something similar to that. That's the acronym. But what is it? Basically, from my understanding, it's kind of like a party line. There's two wires that go around your car, and anybody can jump on, and then you have messages being sent back and forth. And so let's say I'm hanging on to that line, and the message comes across, and I check, is this message for me? No? Okay. I'm not going to touch it then. Next message comes in. It's got my address. Oh, that's for you. It's like a mail delivery system. Is that a good way of describing it? Party line, mail delivery?
Yeah, it's two wires that basically can go through the entire car, delivering messages to all of the different computers in the car, whether they need them or not. So in a lot of modern cars, there could be 7 or more of these CAN networks. But in our simplest case, especially on our conversions, we got basically one network. If the message is for you, you listen to it. If not, it just passes on. And you can be a sender, receiver, or both on these on the messages.
Also, let me add in the advantage. Why would you have this? And from my understanding, the reason you'd have this is to reduce the amount of copper that you have in the vehicle. So, wires. So, for instance, on your door, if you've got a mirror that moves, and you've got like an electronic mirror, and you got a music speaker, and you also have all your windows, and maybe you have some lockouts. If you got all that going on, you'd have to have a wire, a positive for each one of those. And if you got CAN bus, you just have negative, which is the chassis of the car, one positive, and then the two CAN buses. So it reduces all those wires. Is that right?
Yeah, you could basically have a computer in the door, and it's on this network, and it's listening for these messages and doing what it needs to without having to run separate wires to the to the mirror switch for left, right, up, down, and the locks and this and that. You don't have a wire point to point running to all of these things. You got maybe wires running to the computer, and the computer could even be in the door, and then 2 wires from that to the rest of the car that deals with that communication.
Okay, now let me ask one question before we get rolling on this new DIY CAN bus situation. What about what's the situation with the Cybertruck they're talking about using Ethernet, is that right? And so what's the difference between CAN and Ethernet? I just don't know the difference.
Yeah, there's automotive Ethernet, which seems to be the way that things are going these days. So especially when it comes to putting more security on top of these things, you've probably heard of these CAN hacks and such. People have been able to take over the steering on these Jeeps, well, with security and things like that. Allowing any computer to transmit and receive anything they want over this car's network can be a problem. So automotive Ethernet adds another layer of security on top of that. Also, but basically, CAN is a network, so is Ethernet. They're just slightly different ways of doing things.
Is it the same idea, just the 2 wires with codes running across it, or is there something different?
Yeah. Well, Ethernet may have transmit and receive. There could be 4 wires instead of 2, but I'm not totally sure. I haven't done too much with automotive Ethernet.
Okay, all right. What's regular Ethernet? What is that?
Yeah, that's like looks like a big phone plug that would go into your electronic equipment around. It looks like this plug. This generally has it's at least 4 wires that are used, and sometimes more. There will be a separate transmit and receive.
Okay. Talik, I think this is a thing coming up. CAN bus versus Ethernet. Maybe that's a topic.
Yeah, that'd be a good one. We should definitely get Johnny on for that. He said he's still welding right now, so he's got the link. I don't know if he'll be able to join tonight.
No problem. No problem. All right, so let's say hi to Richard Jones first. How you doing, Richard Jones?
Oh, hi. Yeah, I was on mute. Hi, I'm here. Yeah, just listening in.
Okay, no problem. Omar's jumping in. That's awesome. All right, Omar's a car collector. Hey, Omar.
How's it going?
Don't go changing.
Hey, I finally,
Please, me.
I took your advice and dumped all those projects.
Oh, fantastic.
It was brutal, but it's worth it. Well worth it.
Oh my God, I had to go through that too. We're recording, so I'm just kind of tell everybody the context. Hey, Omar, turn your phone sideways or horizontal if you can. It's a better look. Yeah, there you go. So Omar helped build the bus over the summer, and we converted a bus from gas to electric over at the EVLC, and that was a lot of fun. And there was a funny moment where he was trying to decide how to arrange the contactor box, which is not easy to do, and it's got a lot of stuff in there. And he kept changing it. It's not easy, you know. So he's going through it, deciding which one to do. And I started singing a Billy Joel song to him. I said, "Don't go changing to try and please me." And it was funny because for some reason, all my times before that, when I said, "Hey, don't change it, just go with one design," that didn't resonate, but the song worked. So
He just wanted you to stop singing so he would do whatever he could.
It's the overthinking, but yeah.
I think it's because you
No,
need to learn the rest of the song.
That's right.
Oh, yeah.
So, but the idea is, sometimes you let what is the saying? Don't let perfect get in the way of the good, or something like that, where something is good enough to what you want to do. You got to just go with it. Rather, you try to make everything perfect, it'll never get done. You got to make it, work, and then deal with making it better down the line. So sometimes it's tough to keep that, especially when you're under a tough time crunch. When time is very limited, you need to just go with what you got.
Yeah, there he is over the summer working on the contactor box. Here it is.
That's right.
But I should say, Omar, thank you for all your work over summer. That's not easy to do. Under pressure, learning something new, and very quickly, putting something together. Plus, we had like such craziness with this photo. Kevin just about had it there.
Right. All the harness for the battery management system here all got tangled up when we were trying to untangle it. And that we're trying to do without cutting any wires and having to resplice. And eventually we're like, just start cutting wires.
Yeah, the class was life-changing for me. And I'm looking forward to the next one.
All right. Yeah. Oh, we are starting to talk about stuff for the summer. It's scary to talk about because I know we got to top this one. I mean, I don't know if that's possible.
By the way, since we're bringing up the EVLC, this Saturday is the battery class with Lou for I believe both kids and adults now.
Oh, that is awesome. Hey, if anybody's listening, you should hear that again. Lou is a battery expert. He was building battery management systems before you were born. I could say that safely because you're probably not the same age as Lou. It's great. I mean, he's now teaching a battery class. What a cool thing. So this is the EVLC over here. And if you just go to events, here it is. There's the battery class. Adult, register here. Right? Boom. There you go.
Yeah.
$300.
Is how do you take these little 18650 batteries? They look like a big AA battery, and put them into groups so that you can use them in e-bikes and anything up to cars. So,
And I'm volunteering for that. I'm going to help out as well. So you've trained a future teacher.
That's great. And you know what's great about the EVLC is everybody's volunteer, including the teachers. And but the money goes to keeping the lights on and creating more events for people to learn. So for students, but also for adults. And it's right there next to EV West. And so look at that. So from 10 a.m. to 4 p.m. I mean, imagine if you got a crash course in batteries, and $300 is worth it because they're going to supply all the parts, and they're probably going to feed you. I'm not going to guarantee that, but
yeah, say they're free.
oh really? EVLC usually has food, so you know, pretty cool.
It's probably a slice of the largest pizza you've ever seen.
Oh yeah, there you go. Yeah, what did we have?
That's why we had to build the bus just to bring the pizzas in there. You need a vehicle big enough to bring in pizzas.
Oh, and plus you get to see our bus.
Yeah.
That Omar helped build. So pretty cool stuff.
Small part of it.
Oh, this was it. This was the moment where you locked it all down. It was big.
Right.
All right. Well, I'm just reminiscing. So, okay. So let's get to the topic for tonight, which is CAN bus, but not just CAN bus, DIY. So, Kev, you wanna roll us in?
Yeah, so where this comes around, and basically this is how Richard and I met each other, is especially on DIY vehicles, you've got a battery management system that you need to put in here. And battery management systems are often CAN bus based. You need to monitor all your cells when you're charging and when you're driving to make sure you don't over discharge anything, and also to make sure you don't overcharge your batteries. So having all of this information CAN bus base helps a lot in collecting all the data and getting all this working with the rest of your car. So your charger needs to know what the voltages are so it knows when to stop charging. Your motor controller needs to know what it is so it can pull back power if your batteries are getting over discharged and warn you if it's getting too low. Things like that.
Nice.
So
you know,
let me pull up my.
I could help give some context. You know, I mean, we're probably talking to people that have some idea about some of this stuff, but just in case someone doesn't, when you have a series circuit, let's say like you're really basic, we're going old school, like a flashlight from the old school where you got like a C battery on top of a C battery, maybe. Those are both 1.5 volts, and then they're in series, so that's 3 volts. But if they're lithium and you go to charge it, let's say one of them's a little bit high. Let's say one is 1.4 and the other one's 1.3, and then you add you know, 2 let's say you try and charge it, one of them's going to hit the top of the charge before the other one, which means it'll shut off your charger at the top voltage of 3 volts. This is obviously not lithium, but this would be like an you know, alkaline battery example. Well, if it hits the top, one of them, and then the other one's still at 1.4 because you only moved up a little bit, now you got a situation where you have actually not fully charged the pack. And when it comes to a vehicle, that's kind of a big deal. So what you need to do is have them in balance. So you actually burn off the high one and get them matched and then bring them up together. So there you go.
Yeah, and if I'll share my screen.
Okay, I'll stop sharing. You can go ahead and just click that boxed arrow thing on the bottom.
There it is. Okay.
By the hand.
Yeah. Share window. Entire screen. Okay. I'm going to share. Let's try that.
Okay, while you're getting set up,
Can't share your screen for some reason. Okay.
you should
Hold
be able
on
to
a
do it.
sec.
There's no ownership thing.
No, it's saying about rights or something. So I may need to share only this. Oh, can't share your screen. Hold on. Go to system preferences. Sorry. Okay, yeah. Keep going while I try to.
Yeah. Okay. So while you're figuring that out, battery management system also will limit your amount that you're pulling. So let's say you set it for a certain amount where it can't pull a certain amount of amps. You don't want to overstress the batteries. It also will turn off the batteries at a low point so you don't go past and damage the cells. Richard Jones has his hand up. Go for it, Richard.
Yeah, hi. I was going to just give a few more examples about CAN bus devices we may want to put in our conversions. So besides the BMS, the charger is often CAN bus based, DC-DC converter. There are current sensors and voltage sensors. And so all these tools which you can either pull out of modern electric cars or to some degree just buy on the used market. Kind of things you want to put in some cases. CAN bus is common, and so besides the BMS, charger, DC-DC, current sensors, your motor controller, they're all typically CAN bus connected, and so in your conversion, you're likely to connect those all together. And one of the little rules with CAN bus is they're like with the old-fashioned modems, there's a baud rate associated with it. And all the devices have to speak at the same speed, otherwise it doesn't work. So 500K is a common one. It can go up to a megabit per second. Some are 250. So when you're planning out your car, if you want everything to be on one CAN bus, everything has to be the same speed. Otherwise, as soon as you plug something with the wrong speed in, it all stops working.
Yeah,
but hopefully I was buying some time there for Kevin to get organized.
that's okay. Yeah,
maybe in my
more
lab
time.
here, I could show some pictures.
Oh, very cool. I like that lab.
This
is
rather
cool.
horrible looking janky box is the VCU that came out of my son's S10 and then later his Doka. It was the same box that did everything. And on here, there are actually two CAN buses on this particular bit of hardware, because I had the situation where I had a device that was 250K, which was a power distribution unit to power up everything, which was very convenient. And then everything else was 500. So also in my lab here, you might see up on my power supply here, this guy here is a very cool device. If you can see it, this is a ISO IVT. So this is a current sensor here, and then has three high voltage sensors right there. And so this is excellent for monitoring your contactors, for instance. And so this is CAN bus. What else do I have here? Another little sensor right here, which is commonly used. This is a LEMCAB 300. This is just a current sensor. It's a Hall effect current sensor. So you put your fat cable through there. I just have the old power supply cable going through here, but it can read milliamps. And this is a very cool tool if you want to do Coulomb counting and figure out how much current has gone in and out of your pack.
Richard, I hate to interrupt you. I'm very interested in that because I want to do milliamp counting on small electric vehicles as a competition in my classes. So I couldn't find a milliamp counter, and I feel like I want to do some sort of efficiency test. So you have to drop that in the chat what that is, and maybe
unfortunately these are a bit expensive for school projects.
Okay.
I bought two of these together from China, and they worked out to be $80 each. But they're well worthwhile if you're putting it in a real product. And then this IVT up here, this is even more expensive, but it also has the high voltage sensors, 3 on there, so you can watch the voltage before and after your pre-charge, for instance. So this is another expensive, but these are commercial vehicle quality products.
We can do
But,
something
there
much
may be a way to
simpler
build
for what you're trying to do.
a current sensor using using an analog circuit, where you could build it a lot cheaper. Because these have CAN bus on them, which is what we're talking about today. They tend to be a bit more expensive, but you can read current pretty accurately with just an analog to digital converter. Anyway, sorry, that was my little aside there.
No, Richard,
Kevin's getting going.
that was great. No, Richard, that was great. I just got one follow-up question. The first thing you showed us looked like a clear piece of plastic with a bunch of components on it, and you said that was the ECU of an S10?
Yeah, I mean, it's just a plastic box lid that I've got mounted the VCU hardware there, and you know, some cable splitters. Here is an OBD2 interface. You know, that's also CAN bus, by the way. And so that was where the data was coming out. Let's see, where do I have my OBD2? Well, for instance, here I have an OBD2 device here with an ESP32, which is, you know, some code to do with that. But yeah, this was the brains and guts of two projects. Just changed the code slightly for the two different vehicles that it's been in, and it'll probably go in my next vehicle as well, or something very like it.
Wow.
But CAN bus is definitely going to be in there, one or two of them at least.
I mean, some dads change their kids' oil, you know,
I can't
just
do that.
to kind of help out a little bit. You change the ECU and use it as an example in your next project. You know, pretty cool stuff. So very cool, Richard. Yeah, I think this is a good, you know, I'm glad you're part of this. Talik, did you have something you wanted to say or add?
Oh, I was just, because you were presenting, I wanted to make sure the recording was getting what he was showing. That was all.
Oh, okay, gotcha.
So,
And
because he goes, it's full screen for whoever's talking, right?
it's full screen for whoever's talking plus the presentation.
Okay.
Yeah, it puts you in the corner and not the way you're seeing it now in the grid. Also, I want to welcome in Mark Weller's in the house. How you doing?
I'm good.
All right, Mark, you helped teach at the EVLC. You helped me a lot with the wiring diagram of the bus project. We've taught a lot of classes together, and it's good to see him. So this is kind of cool. It's like celebrity EVLC night, and we got Kevin and Mark in the house. Okay, so Kevin, you ready to show us something?
Yeah. So, well, in changing all of my making my settings so I can share my screen, I lost all my tabs that I was doing. So bear with me here, and I'll.
Oh, okay, no problem. We could. You know,
I'll go back and share my screen again. So you see my BMS screen basically.
Yeah, I see the Torque, which is a vehicle, and the Humbug, which is a Torque is like a 3-wheeled prototype, and then the Humbug is a kind of like a Beetle with a military-looking top platform.
Yeah, and this is my display going from, like, you know, end to beginning. This is my BMS in the car. The BMS is all on CAN bus, and it's spitting out to a screen in my garage so I can go and see when I pull into my garage what my battery state is at. So I was just
and this is every single cell.
Oh, yeah.
And so I see I see the second column there. I see 4.05, but then right below I see 3.88. What's going on?
Yeah, well, that's my next dying module right there, obviously. So these the battery modules that are in the Humbug were salvaged from something, and I'm using them for a higher current purpose than they were meant to be, and I seem to kill them on a regular basis. So that's probably the next one to bite the dust. But we're talking about the getting off subject. We're talking about the balance of things, but this is at least where the data is coming in. And yes, this clearly shows you the next battery cell in this whole situation that's going to give us trouble.
And so, going with the theme tonight of CAN bus, how do you, like, just straight up layman's overview first, like 30,000 feet above. How do you get these voltages onto a remote screen in your garage from the battery pack? Like, how does that happen?
Yeah, so going now from beginning to end, these are. Can you see my screen still here?
Yeah, we see your screen, but what you got to do is if you change tabs, you have to follow it. It'll say, do you want to show this one or you want to stop? But while we're talking, Richard Jones, what do you got in your hand there?
Yeah, I was just going to show. This is the little BMS board that Kevin's got in his vehicle.
Mm-hmm.
This is the old Ziva that says 12 cells. It's kind of hard to see, but the 12 wires connect in on the bottom here. And this is the CAN bus across the top. So there's a goes into and a goes out of here. In fact, it doesn't really matter which way's in and out, but there are two wires which are CAN, which are twisted. And then there's power and ground, 12 volt and ground. And this is black and red, which kind of makes sense. And the CAN wires, and they're thicker, and the CAN wires are thin and twisted. And so that's one of these guys. And you can see I've got, it kind of carries along here. And then I've got another one. This is HJ Doka there. So that was my son's. These were actually right off the Nissan Leaf pack that was in the Doka. So this would connect to 12 cells, another 12 cells, and another 12 cells. And instead of wiring out to every one of these little boxes a whole bunch of wires, you just have these 4 wires, which is CAN bus plus power. These run off the 12 volt auxiliary battery of your vehicle. So Kevin's got something similar to this in his vehicle. And then this guy here is a current sensor, a little thermistor. So the little BMS board can read 12 cell voltages that are connected here and 2 thermistor values, which you'd bind onto your terminals or somewhere like that. And then through CAN bus, you can read the voltages and the temperatures off each one of these modules. And each one has a little selector on here, an ID, which basically changes that address we were talking about on CAN bus. So you've got to have them all on different addresses. Otherwise, if they're on the same, they'll be overriding each other with different data. And that can happen as well. So you need to make sure everybody has their own address. And conveniently, these guys have this little switch, rotary switch, to very easily change that when you set up your vehicle or if you're doing experiments.
Now,
so from here,
yeah,
Kevin is reading the data from these guys over the CAN bus, which are these twisted wires here. So
now going with the theme, we were talking about kind of a motivation behind this meeting podcast is that we're going to talk about solving a problem, and then we're going to have a guest talk about how they solve that problem. So one of the problems you have is you have to monitor these batteries, and then those systems are expensive. So you usually have an Orion system, which is a full system. I guess that's you're talking maybe $1,500 or to $2,000. Am I in the ballpark there?
Very expensive. Mm-hmm.
Okay.
Good.
And and then you also have there's another competitor to that. I think D-Lithium would be another one. I don't know what the prices are, but you guys are talking about solving it closer to a DIY level. Are those DIY in that you bought the board and then you put it all together? Is the board made?
Yeah, I've worked with both of those, and they're CAN bus again, right? So the actual messages that come off the Orion versus the dilithium, they're different. You have to go look up what they are. But essentially, at some point, they both give you state of charge, or they give you the cell voltages. The Orion is definitely high-end BMS that does lots of very cool things. It's also a lot more expensive, and it's sort of a central system. And the dilithium is sort of like a modern version of these Zivas. These Zivas are kind of neat, but unfortunately, they're not available anymore. And so dilithium is what we've gone to for other projects since, because it's available, and it follows a similar scheme where you have, in their case, they have 24 cells per box, and then CAN bus connecting them, or actually, in their case, CAN bus talks to their main unit. Yeah, I mean, I've worked with many
So-
different BMSs, and ultimately, though, you've got your array of voltages that, like Kevin is showing on his display, whether it comes from a Ziva or an Orion or a dilithium or any number of other BMSs in your vehicle. Somewhere you need to know what those voltages are, and something needs to make a decision to turn the charger off if they're getting too high, or slow the power down to the motor controller if it's getting too low. Those kinds of decisions.
Okay, I have a dumb question. Well, first of all, let me say hi to someone who just joined. Tom Summers is in the house. How you doing? You got to unmute yourself. He'll find it eventually.
Tom from the Philippines.
Okay, gotcha. Yeah, Tom's coming to us live from the Philippines. He is the donator of the yellow bus that we worked on over the summer, and a very Volkswagen-y kind of guy. He's done lots of stuff, worked on boats, and he's a big supporter of teaching the next generation of electric vehicle mechanics and engineers. So thank you, Tom. And when you figure out how to unmute yourself, say hi. Just to review, tonight's theme is we're talking about CAN bus from a DIY perspective, and what it is, why you need it, and how you can dissect it a little. I have a dumb question for Richard and Kevin and Mark. What's the deal with you want to balance? So I see you're reading the cells with these ZEV controllers or ZEV circuits, but what about balancing? Are they also burning off the high cell? What job, like who's doing that job?
Yeah, so you send these things a message over CAN bus, which says, report your voltage, and this is the highest voltage we would like to expect. This is where you should balance. And I set it at like 4.15 volts. When I send it that message that says balance at 4.15 volts, it returns the voltages of all 12 cells connected here. And that's the way this particular one works. So anything that's above that 4.15 set voltage, or whatever I decided, it'll put a resistor across that battery cell in order to get that voltage down. It's a very, very small resistor, but over the course of a lot of time, it will bring that cell down to that voltage.
And is the resistor in that little gray box that we're looking at?
Yeah, there's 12 resistors across here that are very small. I don't have one of these opened, but they're literally, let's say, a fifth of the size of your pinky nail.
Okay.
So yeah, they don't burn off voltage very quickly, but they will do it eventually.
And are these boards something that, okay, you can't buy them anymore? So is there a DIY board that you can buy to create this?
Yeah.
Is this
So when this company went out of business, they open sourced all of their designs. So if you wanted to, you can send the design off to a pick and place circuit board design company in China, and they'll send you back a bunch of these things. Or you can take it in your CAD program and modify if you want to, and do different things.
That sounds really exciting, actually. I mean, for people like us, I guess probably, but yeah, but you know, PCB way is something that Jehu talks about a lot, and you could just design your own traces, your own boards, and have them set so you could make your own BMS. Is that a possibility, do you think?
Yeah, well, you'd be able to take the files that Ziva has given the universe when they went out of business and send them to PCBWay and have them send you fully populated boards back. That'll work.
Nice.
Theoretically.
Tom's got his hand up. Tom, how you doing? Go for it. Oh, maybe he hit it by mistake. Let me go over to Mark Weller. Let's get him in the convo. Mark, you know, in the conversions you've done and the classes that you're now teaching, you know, just so people know, Mark's kind of like me. He teaches automotive, and very early he just saw the light probably got hit with like a alien laser beam from Planet Electric Vehicles, and he got the message that it'd be nice to have an option besides piston engines. I like piston engines, but they're amazing. But it'd be cool to look at the electric vehicles. So, Mark, have you messed around with the BMS on some of your conversions and in your classes? How in depth do you go?
So I have the main one that I use is the dilithium, and so I've gotten pretty familiar with that. But actually, I'm hoping to learn something from Kevin here and the rest of the guys on here about the CAN specific language. The dilithium, you're actually so it uses CAN, but it also has an ISO. What's it called? The ISO. It has an independent CAN that it talks on from the MCU to the BMS, and so that uses a program called PuTTY, and I've gotten pretty familiar with the PuTTY end of it.
Okay, that's really good. Okay, so I'm just gonna steal your kind of like what you're saying. Basically, you're saying you have a question for them. What would be your biggest question for Kevin and Richard tonight?
Right. Well, so the main thing that I want to understand, I guess, is in the CAN language, and I guess really it's kind of a language, So if you're speaking, French or Spanish, and then so I guess how do you get that CAN language to display, say, on the Raspberry Pi? Like how do you marry up? Yeah, I guess that's my question.
Oh.
How do you marry up the CAN language with the Raspberry Pi or the AEM?
Oh, okay. Can I reiterate that? I think basically a few moments ago we were looking at a display of all the battery voltages, yet all you're getting is CAN. So how do you go from CAN to a display? Is that the question?
Yeah, exactly. Yes.
Okay. Kev and Richard, do you want to take that one?
Yeah, Kevin can show you.
Yeah.
Right.
So, I'd say, it's not a language that these things speak. It's more like looking at a spreadsheet. You got a spreadsheet of a bunch of numbers. That's agnostic of language. It's just numbers. What do you do with all those numbers to make them make some kind of sense? So one way that I've done this is with a Raspberry Pi, reading in this data that's coming in over CAN. And what you're hopefully seeing on the screen right now is that raw data.
Ron, what are you seeing right now?
Oh yeah, I see like a black window on top of the EV West website about the dilithium, and then there's a whole bunch of numbers. Kind of looks like the Matrix. I feel like we're gonna get, like the aliens are about to attack. I'm getting nervous, but I see what's going on there. Go for it.
And and I believe I recognize that as hexadecimal.
Right. There's you can see, because it's not just 1 through 10, it's 1 through F in the numbering scheme. So this is all the data coming back over CAN, and it's up for something to interpret that data and pull out the important messages.
Show
So
cells.
What'd you say, Talik?
Sorry, I just remember show cells.
Oh, that was in the party.
and that's what this message is. I know that this is an example of one of those messages. I asked it to show me all the cells, and this is an example of the numbers it came back with.
So what do we do with those numbers, though? So,
right. So there's then software in between that's written in some language. The software in the case of the Humbug is written in Python, which waits for these numbers to come back, the message number, which in this case is 120. And it knows, 120, that's cell group, 8 through 10 or whatever it is. here's the voltages on that. And I know that the voltages come in as 2 bytes per voltage per cell. And, you know, there's some dictionary somewhere that says, okay, for this message, these are all of the individual bytes of the message that come back, and then this is what they mean. So in this case, I see, you know, OFD4. It's hard to read by a human, but the computer can read it very quickly and figure out that means something like 4.1 volts.
4.052.
Do something with that. What's that?
4.052.
Right.
If you,
Well,
you bring up
because-
your Windows calculator and put it in programmer mode and type in 0FD4, it comes back with 4052, which is millivolts. So it's 4.052 volts right there. So you can easily, you can manually decode any one of these voltages. Oh, that gets tedious and way too nerdy for most people. But
How do you know that it's volts?
just from reading the spec of the, whatever it is. These are Zivas. It's a little different on dilithium. On dilithium, you type in the show cells, right? They show it directly. This is the raw data coming over the CAN bus. And dilithium can do a similar thing. It can dump cell data over CAN bus, and you have a similar decode. But the address would be different, and maybe the ordering of the cell values would be different. That's where you just have to RTFM, and they describe what the contents of every byte of every message is. And then you get someone clever like Kevin to turn that into MQTT and actually show it on a screen for you, or however you want to display the data.
So,
okay, so let me fill in a couple of blanks that that I probably would have these questions had I not gone through the CAN bus boot camp 2 summers ago. I know that they are in binary and hexadecimal, and basically you have to break these things down because if you're not coming from a computer science background or some sort of heavy math set background, this is like voodoo. This is like, what is this? But it actually makes a lot of sense. It's just a way of compressing longer numbers, from my understanding. And the other part that I should fill in the blanks about is the putty is like kind of a terminal, and so it just reads what you're sending it in, and it's just like, I think what Kevin's saying is a spreadsheet. Would that be? Let me see. What else are we not filling in that we're missing? Mark, is there something that we're not filling in here?
Well, actually, I think Richard, so you said that Windows, you were able to plug in the hexadecimal into Windows?
Yeah, if you bring up Windows Calculator, it has a mode called Programmer, and that can convert binary to hexadecimal to decimal, just the Windows. I guess you're on a Mac.
Here it is. It was
0F.
What was it again?
It was OFD4.
D4. So that's a hexadecimal number, and I can convert that to a decimal, and it's 4052. So somewhere in the dictionary of this message, it says this is the voltages for cells 3 through 10 or whatever it is, and it's going to be in millivolts, which is thousandths of a volt. So it's 4,052 thousandths of a volt, which comes to 4.052 volts.
Nice.
And that's what it's telling me. And in that case, it was going back to here.
Really? So there's 2 digits, then a space, then 2 digits, and so
Yeah.
we're looking at
So
how many is there?
Yeah, it's gone off to another message here now, but let's see, I'll get it back again. Yeah, there's 8 bytes here.
Are they seeing what we're looking at?
Yeah, yeah. So it's knowing in these 8 bytes, here's one of them here that's It's 1, 2, 3, 4, 5, 6, 7, 8. So it's this group of 2, this group of 2, this group of 2, and then this group.
Okay, and is
Kev,
that the 8 in the brackets is beside it? It says that
It's just saying it's 8 bytes. Yeah.
it's 8 bytes. Okay, but so the voltage wasn't all 8 bytes. It was just the first 2 bytes. Is that how that was?
Right. Well,
Is
in this particular case, it's these 2 bytes. Then these 2 bytes is the next voltage.
Okay, so like how would we know? Oh, so it's a voltage. How would we know that that's a voltage?
Yeah, when you look up the dictionary of this CAN message, it'll tell you what is encoded into all of the bytes of this message. And then it's up to you to either write the software to pull that apart or use something more intelligent like the AEM display to display these voltages, to display
Okay.
this data.
I have a dumb question.
There are
Is
no
it-
dumb questions.
Is it possible to get an AI like ChatGPT, which I heard can do coding? Can you ask it to write a code that will interpret these hexadecimals into your voltage display? Is that a possibility?
I mean, yeah, there probably is. You can guide it through that and then probably stitch together the bits and pieces. But, you know, it doesn't take a level of artificial intelligence to do something with this. It just takes stealing code creatively from sources on the internet and putting it together. And that's all I do, basically.
So
Okay.
that whole rabbit hole process we just went down, is a good analogy for this potentially kind of like MP3 encoding a song from a wider and then compressing it, and then on the other end you have your MP3 player which can decipher the music.
Yeah, I mean, sort of. It is squashing the data down because you've got a limited wire here. So it does squash everything down into a smaller format you can see in these messages.
Now, before we get to the next section, which I hope is showing us the code, or at least how to work through the code, Kev, sometimes I like to ask people that are smarter than me, are we asking the right questions?
It's good, yeah.
Yeah, well, I mean, yes, I think so. I try to go about explaining things from a point that I don't know everything. Like, what did I need to know when I started this? But sometimes I'm too deep into it, so I may start getting too deep and not going in the right order. So perhaps
Okay.
I should make this into a PowerPoint or something that's more step by step that would make more sense. I'm sort of doing this on the fly here. So
No, you're doing great, because I think that Mark had a good question. Basically, I think he wants to know, how do you interpret this, this data into a display? And I think the next step is you're going to show us, not that we're going to like learn code here, but you're going to give us an overview of the code. Am I right?
Yeah, I'll give you the brief overview of that.
Okay. Can you make that window bigger?
Yeah. How's that?
Yeah, it's better.
But you can also see, along with all of my voltages, I have a lot of other seemingly BS messages coming in here that I'm just ignoring for now. They're not important for what I'm trying to do, so I just let them fly right by me. There's this message, which you see has a much larger number to it, that I'm not concerned about. My program will just ignore that.
Okay. And what could that possibly be? I feel like Mark would ask that.
Yeah, so there's other things on this CAN bus, like my GPS for this car, which monitors my speed, because the speedo in this car is very unreliable. It is my speedo, but it's also I log all the data from the car as I'm driving it around. And if I see that there's a big voltage dip or something funny happened, or there's a point where things went weird, I want to know, where was I driving at that point?
Oh,
So
that's a great idea.
Yeah. So, well, this
That's
GPS, gives me that information as well.
Okay, while they're on the topic, in case I forget, I've always thought that if you're doing a custom car, would it be beneficial to have some sort of data acquisition? And so, when you do a custom car, there's excitement. You finally get the thing running. You take it to a car show. Everyone's excited, but you're not thinking about data acquisition. And so I think that data acquisition would be great because besides just the BMS, because if you have an issue, where on the road did you have the issue? Were you climbing a hill? Were you charging? Where were you? How long were you driving for? Which component do you think failed? That would be great to log. And then you could learn over time as you do these conversions, which components are more reliable for what you're doing. So this is great stuff you're doing. Now, is that because you have on one CAN, you don't just have the BMS, you also have your GPS? Is that why?
Right. I've got GPS and I've also got a current sensor. But I could be gathering data from multiple sensors all over the car to go and give me data back that could be useful later in analyzing my problems, or maybe tuning the car for better range or anything. In my case, I make a giant CSV file, which is basically an Excel spreadsheet that gives me the time. This is the time in seconds since January 1st, 1970, which is just a convention called epoch, Linux epoch time. But I know the exact time of day down to the second from this number. All of my voltages, my current, some temperatures and other things are in here, my latitude and longitude at the time, and a whole bunch of other stuff, which I've since forgotten even what it means. But yeah, I gather all of this data all the time while I'm driving, while it's sitting in the garage.
That's pretty cool. Have you done any analytics based on that? Did the GP? I mean, you may have a future idea, but did the GPS or the current sensor help you out?
Yeah, absolutely. Especially in the beginnings of this car, I'd go back and I had a script I made that would graph this all out. Graph my battery voltages along with my current, and then I can refer back to where I was, latitude and longitude at the time too. So for example, I'm trying to find where my weakest cell is. It doesn't always show itself while you're sitting in the garage or while you're charging. Sometimes it's when you have your foot all the way to the floor. You want to see which battery module, which battery cell is dipping down the lowest, and that's probably your next one that's going to go on you, or that's probably your weakest link in the chain.
Got it. Pretty cool. There's also some other stuff that's, I guess, possible. For instance, sometimes when I charge at a particular house, they have a small breaker, let's say a 20 amp breaker, which is surprising. Usually you have a 30 amp breaker at least on a 220 line, and it was a 20 amp breaker on a 220 line. So I have to dial it back, but the Tesla will remember that at that address,
at that location.
Yeah, I don't have to set it, and if I change it, it stays changed. But if I go to someone else's house, it'll just crank it up to whatever it was supposed to be, like 30 amps or something. So pretty cool. I guess you could do stuff like that. Yeah, that's pretty cool.
Yeah, you can put all kinds of intelligence in there. If you got the data and you have the imagination, you can put all this intelligence in there.
And now, Mark, do you think there's any merit to having data acquisition on your educational service cart?
Yeah, I'm not sure. Until I get it figured out, I for sure can't teach it. But it would be nice to be able to do just some, just some basic exercises with it. But I mean, for the moment, particularly on the conversions, we don't have that many things, I guess, that I guess like, if you have a full blown Tesla, you've got a lot of things that can go wrong. We only have so many pieces, like on the yellow bus, and basically you've got, the batteries, the inverter.
Yeah.
Pretty much that's your.
Right. This would have been really valuable on the yellow bus because we had times when it wouldn't charge and we didn't know why, because there is no display in the yellow bus right now. And there may be a fault light that comes on to say there's something wrong, but we don't know what it is. But any number of things could be wrong, causing it not to charge.
So with the data acquisition, that would just tell you where and when it stopped charging.
Yeah, well, you'd have the temperatures of all the batteries, and then maybe you'd have the fault code actually in here, which would say, I'm not charging because battery number 3 temperature is too high. That was one of the things that happened recently. If you had the visibility into this data, and all of that data is available on CAN, as well as under PuTTY, which we were talking about before, which is just a command line terminal, which you're looking at on my screen right now, of the data coming in. You'd have that, but you have to have access to that data to be able to look at it in some way. And people don't want to be looking at a screen that looks like a bunch of black and white numbers on a screen like this. It's too confusing. You want to put it in a form that's easy for people to read.
For the teaching card, would it be beneficial to use CAN data collection like this to either formulate an exam or a quiz, like working on the card, like, okay, you plugged in this in this order of operations or something like that?
Yeah, I'm sorry, I'm not sure. I'm just getting a feel for it as we go here. One of the things that he has the AEM display up there. One of the things that I do think would be beneficial actually is let's say, for example, I don't want to put Richard or Kevin on the spot here, but so with the AEM display, you can change different screens. And one of the things that I was thinking about doing was setting up a screen that would be like a lab activity where on the screen it would say, unplug the temperature sensor and and see what happens. And then embedded in that same screen, it would have the temperature sensor, and it would just show the you could put on the AEM, you could put a picture of the temperature sensor, and then have an arrow where you're showing to disconnect it, and then you would have the reading, and then the students would be able to actively watch the reading change.
Yeah.
Or like a cell tap, it would say, unplug cell tap, from module 5. And then it might show you a picture of where module 5 is, and then the students would go into the battery pack, unplug that one, and then you would see the actual voltage value as the temperature change.
Right, because you're causing a fault, basically.
Yeah, and then they can scroll, use the menu button to scroll to the next screen and say, okay, now go and maybe I don't know, do some other fault. And then you would actually within the screen you'll be able to see what happens. It would show you in the screen, and then you would be able to do it, and you would be able to see the result right there. But I don't know how to make that magic happen. So.
I like that idea because you're learning through failure, and that's a super important thing.
Right. I think what would make more sense, and not to get too far down the rabbit hole, is like on the laptop that comes with the cart. This is the teaching exercise, and it shows you, and then it says, now go to screen 3 on the AEM, and you'll see that the temperature dropped to -20, which obviously doesn't make sense. And then you say, aha, I see that. And then you'd say, find where the fault appears on your AEM display. And you'd have to look through all the screens on the display to see where does it say, I see a temperature that makes no sense, which would be a fault, some kind of fault that it's generating.
Can you, Kev, since you're displaying stuff right now, can you just for a moment put up on the screen the trainer cart, just so people know what we're talking about? Mark's done an incredible job assembling a car on a cart, and it's a conversion cart. So you have a situation where if you can build this, you can build your car. Is that how you describe it, Mark? You want to give us a little intro about this?
Right. So that's, yeah, the idea was that to have just the electric vehicle portion of the car, have the whole thing, no simulators, no pictures of parts, but have the whole thing actually there running. And you could be able to take it off of the cart and put it in an actual car and drive it down the road.
Can you guys
Yeah.
click on the picture and make the picture bigger? There
Oh,
we
yeah.
go.
That
Yeah.
looks better.
Yeah, so it comes with that laptop and it comes with the AEM display. Yeah, it's everything
Tesla. It comes with six now. How many? Four Tesla modules.
4 Tesla modules. Yeah, it's a 100 volt Hyper 9 system. And yeah, so we're just trying to figure out basically some more activities to do with CAN and how to incorporate more of that stuff.
Pretty cool. Pretty
There's
cool.
actually a motor on the car.
Yeah, you do have the AEM display, which can show you the values coming off CAN, and so Kevin was showing you the low-level values, but of course AEM understands them. It knows the CAN messages coming from the motor controller, and I guess now the dilithium BMS that's on it's dilithium use on that, right?
Yeah.
So the AEM can have a screen that shows the cell voltages for you and the temperatures. So that's basically a bit of software running in that fancy expensive display that decodes the values off the CAN bus again. And so this cart's awesome because you've got a CAN bus on there with a motor controller, BMS. I'm not sure what the DC or current sensor is, and then you have a nice display there, which is interpreting those CAN messages for you. Half the trouble is figuring out what screen on the AEM to go find it, but that's another thing to learn.
Well, and it also comes with a laptop to make your own screens if you want to on the AEM. If you want to make a screen that shows high and low battery temperatures, you can do that. So that's a valuable skill to have, to know how to reprogram this display.
Yeah,
and
actually, there's another terminology just to make that transition. So you've seen raw CAN messages, and then we've actually used a hex editor to actually go figure out a value, and then we happen to know that's the voltage. But when you're working with a tool like the AEM, they use terminology like signals, CAN signals. And so you have a CAN message, which has up to 8 bytes in it. And then there's a description called a DBC file, a database file, which use the terminology of a signal. And so a signal might say the first 2 bytes of that message number 123 is cell 1's voltage, and it's interpreted this way. And you have a minimum value and a maximum value. And then with the AEM, you can work if you have these magic DBC files, you don't need to look at the bits and bytes of the individual CAN message. You can go select cell 17 or temperature 23 or whatever, and then pop it up on the display without having to get that lower level. So for most people, that's probably, that's the value of a display like that. While it's rather expensive, it does save you a lot of time and not need to know every last bit and byte down on the CAN bus. But then when you're teaching, it is good to know how to troubleshoot when CAN bus isn't working, right? Or parts of your BMS isn't working if the CAN bus is working, but you have a cell temperature sensor that's not correct, the troubleshooting techniques, good to do.
Nice.
Yeah.
Most people hopefully don't need to worry about, interpreting individual CAN messages, but it's good to show briefly what they look like.
Right, and all of what we were just looking at on the trainer cart there, the DBC file, Michael, he painfully went through and set up that whole thing. So AEM didn't have a DBC file for the dilithium or the net gain. And that one, it uses the dilithium and the net gain. Those two CAN networks, I don't know if they were a different speed. Something they were not able to talk on the same.
But fortunately, you can change the speed to make them match. That's part of the setup of things.
So the AEM, it has two different pages that you can set up. So the dilithium is on one page, and the net gain is on another page, but they're merged. When you're looking
actually,
at
the display has multiple CAN buses on it, so you can set one up for one speed and the other one up for a different speed.
Yes,
and then the display can show both then.
Right. Yeah, and that's what Michael's already done. So he's made that very very easy, but you can still
yeah, the DBC file represents a lot of time invested to get it right. And there are tools out there to create the DBC file. So when you have a description of what, like say dilithium's manual, go in the back of that. Once someone creates that DBC file once, it can be used in AEM, but it can also be used in any other tool out there that uses this industry standard database that describes CAN messages and the signals within them.
Yeah, it's the dictionary that I was talking about before. It's a dictionary of what these signals mean. So, yeah, to move along on the, like I was doing all this on the super cheap. So I instead have this Raspberry Pi on here, and I wrote my own software, and it was, under $100, but I've put in lots of hours in writing this software already.
You got more time than money.
Yeah, well, I got more, I got less brains than sense or something like that. Would be I would have laid out the money, but I'm always in my brain thinking this stuff's a whole lot easier than it is. And then, I get down to it and realize how difficult it is. But for what I needed to do, this was perfectly good for the case. So, here, I'm not going to, teach Python here, but this is the Python code that is sending out once a second all 3 messages to the 3 different BMSs to tell it to report its voltage and to set the voltage of the shunt of where to bring all the batteries down to. And then somewhere down below here, I'm interpreting the messages when they come back. Anytime I get any message back, I do some stuff to it. I know that 301, 302, and 303, those are all voltage messages. And I wrote a program or a function within here to take that and stick it in its proper voltage slot.
Nice.
And then from there, I'm making that big CSV file that I was showing before, which is all the voltages, currents, temperatures, everything that I'm getting on CAN and sticking it into a spreadsheet.
And your Zilla temperature too.
Zilla temperature and everything. So yeah, I'm taking serial data and all kinds of stuff and sticking it all in here.
I thought it was just the BMS on your display. I didn't realize you had your motor controller temperature as well.
Yeah, well, as this software has evolved and I've gotten access to more data, I've added more stuff in here. So I put that in here as well. It works about a quarter of the time. So I also make sure my software doesn't fail if this information isn't available. It goes ahead and logs anyway. GPS isn't working because I'm inside in my garage. It doesn't log GPS. You can see one of my signals is in here. Is GPS valid? So I know that I can just toss it away. If it's not valid, if I'm in a tunnel or if I'm in a garage, also it tells me number of satellites in use for GPS, which is important. If it only has 2 or 3 satellites, I know that the information it's giving me is not going to be very accurate.
You can tell that from the GPS?
Yeah, this was, I think it was AEM that made this little GPS module. It was made for racing, for race cars specifically. And it tells me GPS location every 50 milliseconds or something like that, something crazy.
Wow.
And that was probably the shiniest thing on the CAN.
Now, there was some device. So, okay, now okay, well, let me ask you a dumb question first. What's the difference between the Arduino
GPS
and the, this is Richard. Richard, tell us what that is.
It's just the AEM GPS module is not available anymore. I had it in my vehicle too. And so it's one of my little projects here is this is a $30 Adafruit GPS module that runs on top of a ESP32, another like a $20 box. So this is a potential replacement for the not available or expensive GPS units.
Yeah.
And then that could send out CAN messages the same as before, and then it would end up as a replacement without having to change any software, hopefully. But one of the other little projects I haven't finished.
This is cool, man. I'm learning a lot. You know, I mean, some of this stuff is over my head, but what I kind of get the concepts. You know, just so people know, Adafruit, New York City based. I guess board hardware. They do like yeah, they'll make Arduinos. They're like an authorized Arduino maker.
Mm-hmm. Yeah, one of the many Arduino. So you can do a lot with Arduino, Raspberry Pis, another embedded system if you want to write code for.
The wild thing is
GPS units are, you know, just like using analog sensors on Arduinos to read current, like from what you were talking about earlier. There are cheap and cheerful maker type projects that can be done, where basically the cost is in your time, not in the cost of the equipment.
Right. It's funny because basically this is a STEM topic. This is basically shop class reinvented. You know, the shop classes are you know, they're changing brake pads when they should be changing Arduino units. You know, it's like
or writing new code to get more insights out of your vehicle than you thought you needed. So
or how do you recreate the functionality of an AEM display with Arduino and other components, you know, and learning the hard way.
And even making it better. So maybe we're taking in inertial sensors and things like that. So while you're racing, you can see where's the point where you had maximum sideways G forces, and where's the point where you think your wheels broke loose. And oh yeah, there's Richard's AEM clone sort of thing, which is using a commercial program called Torque to display all of the data coming through on the car.
Richards, tell us what we're looking at here.
Yeah, so this is a cheap tablet. This is a Kindle Fire. I think it costs $80, and it's running a $5 Android app called Torque. And in Torque, you can make your own displays. And so this came out of one of the vehicles I did, and this is showing, you know, cell voltages down here and currents and things like this, you know, data you might want to look at from your vehicle. So similar to what Kevin was showing on his Raspberry Pi and then the display, this is showing instantaneous data on different screens, you know, depending whether you're driving or charging or whatever. And most of this data came off CAN bus, you know, for instance. So this could potentially be a display in your vehicle, and it's considerably less expensive than the AEM one. Although when you figure the time involved in getting it all going, then maybe the AEM one's cheaper. But
let me add this. Oh, go ahead, Richard. Sorry.
No, that's it. I was just to show other ways to showing the data for troubleshooting purposes or whatever. And I love what Kevin's done with everything being logged, because you can then do a graph of your drive and then figure out where your lowest cell was because you were going up a steep hill, and see the temperature of your motor controller going up. You don't get that with this is just showing instantaneous data. You don't get the history with this, although it can log data too. But what Kevin's done is very powerful in that you can then bring other tools to bear to go and see what happened on that drive. You know, and I think that's very cool.
Would that be useful for go-kart racing, electric go-kart racing, analyzing your run and maximizing your results? Would that be good, Kevin?
Yeah, I see a system in there where you have a very cheap ESP32 that's logging data and transmitting over Wi-Fi to a central place, because, you know, go-kart tracks aren't all that big. And so then one central place is gathering data from all of the carts, comparing them to be able to show who's in first place, second place, who got their batteries the hottest, who had the most
Who is
sideways.
heaviest on the throttle?
Yeah, all kinds of stuff. So,
So just
yeah,
planting a seed for the summer.
Yeah.
We're talking about doing
Right.
something competitive.
right. And we can take any one of these topics here and make this a class for STEM for kids. Yeah, how do we make this out of big, heavy, dangerous, expensive cars? How do we put this down to e-bikes or go-karts where we can teach this to a classroom of kids?
Yeah, this is great. This is a good discussion.
Stuff.
I just want to back up Richard's display there. Bring it to layman's terms. The Torque app that he's talking about is not so much a is not so much a mystery. It is something that a lot of people use. All you got to do is it's an app. It goes right on your phone or on a display that he has, and then you can actually wirelessly connect it to a Bluetooth dongle, which I know that I always thought that was such a funny thing to say, but anyway, it's a little thing that fits in your hand, and it goes to the OBD2 sensor, which plugs into any car after 96.
The one that
And I-
that'd be hard to display on there.
Yeah.
Yeah,
Right, and
okay.
we'll totally
Mark,
be able to do.
you want to add something?
Oh, yeah, here's a cheap one.
There we
Yeah,
go.
absolutely. So like the trainer cart, yeah, it has an OBD2 port through the dilithium.
Mhm.
And yeah, I mean, that's why I would love to be able to, to marry up the cart to the Torque app where students could be on their phone, where they would download on their phone and then connect to it and be able to manipulate it and do that on their own. I think a lot of it's like we're talking about it, but I think a lot of it, like just have exercises where we just do it. Or like if we're going to do like a class or like in the 101 class where the students will just bring their laptop and everybody download the Torque app if you don't already have it. Okay, now open Torque and connect to your Bluetooth. Okay, now we're going to take the can sniffer and sniff out whatever hexadecimal number and pair it up. And then okay, now we're gonna just set up this one. We're gonna practice taking one CAN message and marrying it up with the Torque. Like
Yeah.
like,
To be honest though, since you've got that AEM display, that's the most direct because it's connected to the CAN bus directly, and it's using that DBC file with a signal that says, this is cell 27's voltage. That's the closest you're getting to the CAN bus data coming off the dilithium or the motor controller for its temperature or RPMs. OBD2 adds, another thing in between, which is the Bluetooth interface. And then, then the Bluetooth is going to an app running on a phone or a tablet. Okay. So it does add some extra stuff. And I've spent many, many hours coding up the gateway software that basically understands CAN bus on one side and then invents special messages for Torque on the other that shows all these cell 1 through 128, same for temperatures, motor controller. I had to create all what they call these custom IDs because they're not standard in the, when you're doing your smog testing of a car, which is what OBD2 was designed for.
Right.
Smog testing gas cars. So everything has to be sort of custom on there. So if it's teaching kids about CAN bus and what happens when a sensor goes bad, I think since you have an AEM display there, use that. But then this would be like a separate project, which is how else can we display the data that's on the CAN bus? So Torque on an app that's on your phone. I mean, a lot of people have Torque running in the head units of their cars, right? So you have these stereos with Android Auto and whatever. So Torque can run right in there, and with the Bluetooth, with one of these guys in your vehicle as well, CAN bus is coming in. You can see the data from your car, but Torque is really geared towards gas cars. And so with EVs, there's this extra work needed to create those custom IDs to show cell voltages and motor controller and so on. There is some folks out there that have basically taken the RPM of your EV motor and have that show on the standard RPM for torque. But things like cell voltage 27 just doesn't exist in the standard messages out there. So something has to translate.
The torque thing is it's another way to do it and give people the flexibility, and it works on your existing gas cars. It works on all of them. In trying to pass smog this week, I was trying to get it working on my Pathfinder, and it's got a lot of really cool information. And you can make all these custom screens. But yeah, the AEM stuff is way more powerful and is closer to the CAN.
Cool.
So
yeah, I just want to interrupt for a second and introduce Jonathan Knight.
Audio? No, no wonder nobody's interrupting me. Hold on a second. I can't hear anything.
Oh, really? You can't hear us?
Oh, we can hear you now.
I can hear you. Okay.
Okay, I just want to interrupt for a second and just say hi to Jonathan Knight. How you doing?
Hey, Ron, how you doing?
All right. You're Homebrew Auto, right?
No, actually, I was at the Learning Center back in June.
Oh, okay. Okay.
Yeah. So I'm
Nice.
just tuning in just to listen to the chat and try and glean some knowledge and all that. So I'm happy to be here.
Yeah. Oh, that's good. Wait, did you you were on the bus project?
No, before the bus project, I think the weekend class.
Oh,
101,
yeah.
3, I think.
.4 maybe.
.4, okay.
I thought I recognized you. Okay. And
Yeah.
Have you been working on an EV?
Yeah, I have. I've been working on my Honda continuously since then, and getting a little progress here and there.
What Honda you working on? Because Mark's going to ask you that because he has a Honda.
Yeah.
I've got a 75 Civic. It's a wagon. And basically, it was just a rust bucket. And I've been working on restoring it as I go, trying to get all the components together to convert it. Today, I just tuned in after I got home from the shop where I was welding tons of metal bars together, trying to figure out how all the components are going to go into the engine bay. It's my process. It's a little artistic and not so well planned, but it's getting there little inch by inch.
That's okay. That's it's not easy. It's a custom project. Can I ask you how you found our get together podcast here, the EV community?
I saw the link on the recording from the last one.
Oh, okay. Oh, okay. So you saw it on my YouTube channel.
Yeah, that's right.
Oh, okay. Perfect.
Audience
All
is
right.
growing.
Yeah, good to know. I never know how anybody finds anybody. It's amazing to me.
On
where
that note
are you located? Oh, sorry, Talik. Hold on one second. Where are you located, Jonathan?
I'm in Marin County, California.
Okay, cool. Well, keep us up to date with your project, and I hope this helps demystify a little bit of the CAN bus. Did you have a question for Kev or Kevin or Richard?
No, I'm just listening in, but appreciate you guys allowing me to be here.
Oh yeah, no, you're welcome to be here. This is the Rising Tide Lifts All Boats podcast. We're all trying to help each other.
Right on.
Talik, yeah. What do you got, Talik?
Well, I was going to say, he mentioned, the stage of the build where you're trying to figure out where all the batteries go, and you're just kind of eyeballing all that. Today, when I was over at Revolt, Anthony from Volt and Steel was rolling by, and I'm not going to say which project it was, but you can check out his social media to see which one it is. But basically, a car, the shell of the car, and they're out there with tape measures trying to figure out where, okay, you can put 2 Model S modules here, you can put 4 here, you can maybe do here, blah, blah, blah. And that's a really fun part of the project because you're just kind of brainstorming and you're thinking about balance and weight distribution on the car and all sorts of stuff. And for me, I think that's a fun part of the project because you're in the sort of the configuring designs sort of it. And then I thought I heard Tom. I don't know if Tom had a question earlier.
Oh, well, Tom, I think had a Wi-Fi issue, but I want to talk about what Tal's talking about for just a moment. We're gonna go by problem or topic based, and then have a guest sort of back up those topics. So tonight it was, how do you do DIY CAN bus? And Kevin is and Richard are great at just explaining this. But one of the topics which I don't think gets enough attention, for another episode, is, where do you put everything? Literally, like the CAD. And I think we went over this on the last episode, but we were kind of unprepared. So where do you put your motor? Where do you put your batteries? How do you package the vehicle? And that's an art in itself, but not electricity based. So that's one of the topics coming up.
Yeah. We were
okay,
thinking about how do we combine CAD and maybe 3D scanning and all of this stuff to figure out how to get things to fit, and how do you custom fabricate brackets, and CAD can even do weights and balances too after all this is done, and when you put it all together. So we're looking for an expert on somebody who can fill in some of those topics, especially when it comes to the latest in 3D scanning of cars.
Yeah, and it was either last week or 2 weeks ago. We also talked about like foam mock-ups of motors, and I think it was actually, when I was looking at this car today, having some like a 16 foam Model S modules would be great, because then you can physically just shove it in there, and of course, if you're not squishing it, you can see if it fits.
Yeah, right, and they're not heavy and dangerous and awkward and expensive if you drop one. So yeah, that would have been great. And trying to fit batteries into the torque. So I do have only about 20 minutes left.
So in the interest of time,
bring in Pumpkin.
Kevin, was there something you wanted to? Was there another device, this round device, you wanted to talk about?
Yeah, well, I wanted to bring it on home, and one more piece of the puzzle here. So on the Raspberry Pi, living on my.
Wait, let me interrupt you for just a sec. Stupid question. What's the difference between Arduino and a Raspberry Pi? And my understanding, layman's, Arduino is can do like a couple of tasks, whereas a Raspberry Pi is more of a computer where it can do like a whole processor.
Controller, they're both computers, right? But the Raspberry Pi can basically it's the power of a whole desktop computer that's about the size of the palm of your hand. Almost fits in an Altoid box. And it runs a full operating system, so it's good at running many programs at the same time.
Good.
In my case, that's what I have in the Humbug right now. And then Copperhill, I've got boards that sit right on top of this Raspberry Pi computer that read in CAN. I'm really trying to find this stuff on the fly here.
I could help with that if you'd like, but you're doing a good job. It's kind of makes sense. You got the Adafruit. Yeah. Basically, you're talking about putting them right there. So you have the Arduino, Raspberry Pi, and then your Bluetooth on top of that. You said, right?
The CAN board on top of that.
Oh, the CAN board.
So what this board is that I have put on top of here gives you CAN interface to the car, and also has a power supply board on it that takes the 12 volts from the car and brings it down to the 5 volts and 3.3 volts that the Raspberry Pi needs.
That's convenient.
Yeah. So you don't need any other kind of external power supply. And that's pretty nice.
DC to DC converter.
Yeah, exactly. It takes, the 12 to 15 volts that'll come from a car and take it down to the lower voltages needed for this Raspberry Pi. So that's what I have running in my car right now, and it's pretty convenient. Oh, actually, I have, let's see if I can, Don't look at that. That little Raspberry Pi thing right there is running my Harley display sitting right next to it. So it has the CAN board on top of it too. And that's really nice because yes, it is a full computer. In all the demonstrations I've been doing today, I've been doing a remote screen over to my computer in my Humbug in my garage, and I can get to it and use it just as if I was sitting in front of it with a monitor plugged into it. I could be playing Doom on it at the same time while it's gathering data on my car. But
Okay.
the downsides are it's not automotive grade, which means it's not happy when power gets interrupted in the middle of something, or if you have power glitches. It doesn't like to be powered down and powered back up quickly. It can corrupt its internal little hard drive. It also takes a long time to boot up because it's got to boot an entire Linux operating system. But so, in the meantime, I've been playing with little devices like this microcontroller, basically Arduino based controller with a screen on it that also has a little CAN interface to it.
Can you pull up that on your screen as well, besides showing it?
Yeah, I have that. Let's see, M5 stack. This
There you
dial thing. So
what is that thing?
So, it's a little 1.28 inch screen on it with a Arduino. It's got 2 processors. It's got a little bit of memory on it. It's touch screen. It's got a rotary encoder, means you can spin this thing to change menus and things like that. Really cool little device. And me with my eternal optimism, thinking it would just take me a few minutes to get this working and replace the Raspberry Pi in my Humbug as well as in my Torque project, and put this in there instead. And
But okay, a dumb question. Got a dumb question. But I thought you need a Raspberry Pi and not an Arduino. If this is closer to an Arduino, isn't it limited in its functions?
So it is, and there's pros and cons here. So it does boot up very fast. It does everything I need to, but it's a little bit harder to program. It's got less memory to it. It does one thing and one thing only, which is, runs one program at a time. But it's cheap, $35 plus the CAN thing was another $10 or $11, and it totally works. So in my car, this could sit on my dashboard. I know that it's managing my BMS for me from the software I've written, gathering all the data from my other modules in the car and displaying them in this cute little round display.
Cool. Is this a new product on the market?
I think this one's fairly new, but this sort of thing's been out for a while, and screens in different sizes. And we talked about Adafruit. They have a bunch of these ESP32 based processor boards, with some with screens and some without. For most of the stuff I'm doing, I don't really need a screen, but it sure is cool to be able to show some of this information.
Yeah. Wow.
This would be cool on the bus to be like, just show me battery temperatures. I turn the dial and it shows me battery voltages. I turn the dial, it shows me my speed, because the speedo in the bus is like bouncing around like this. You can't see anything, and it's in kilometers.
What would it take to install that in the bus? Like, aren't you just hooking onto the CAN wires? And we ran CAN wires just in case.
Yeah, that's what I've been told, but I haven't been able to find them yet. But
talk to Ali. We ran them for sure. We've been talking about
that for 6 months. Somebody's got to find them for me. But yes, they're potentially there. So hardware wise, it would take 5 minutes to get it going, and then I got to write the software to make it happen. But with everything I've learned in the past couple of weeks of getting this working with the Humbug and the Torque, we're we're not too far off. So
Very cool. Jonathan, are you listening? Can you run the extra CAN line to your dash so we can install this dial thing?
That looks awesome. Definitely.
Yeah, man.
what is the motor setup you've got in your Honda project?
I'm working with a Coda motor that I got at Thunderstruck. So the Coda motor and inverter and charger.
The has CAN bus too.
Yeah, it
I'm
does
not
have
familiar with
cameras.
the Coda motor. Maybe Kevin, can you pull that up?
Yeah, the Richard is very familiar with them because that's what's in the Mustang, right? Isn't it?
Yeah, it's in the exactly. Yeah, good luck finding it.
I know people that used to work at Coda, and there's a Coda Motors dealership. No, I don't think so. This is very risky to do here, real time here.
Oh,
You'll see
okay,
it
no
on the
problem.
Thunderstruck
It's,
on the Thunderstruck website they have.
oh,
Yeah.
this is a recycled motor. Is that right?
Yeah.
Got it.
From
This
this,
is
it looks like a Mitsubishi
defunct,
Galant looking car that was.
yeah, this is like a defunct car.
Yeah, they're like a Chinese, looks like a Geo Metro or something.
Got it. No problem.
There you
I thought
go.
it was a new thing that you were talking about.
No, that's the setup there.
Yeah.
But
I
it
think that's
just.
actually an American company, not Chinese. The UQM Power Phase
Oh yeah.
AC.
yeah.
That's a nice
Induction
motor for that price.
Yeah, it's
And
100
it's
kilowatts, isn't it?
new, not something used from a wrecked car. So
Yeah.
there's
Pretty
advantages.
cool.
So
Well-
yes, it could totally be done, and it's just a matter of somebody writing the software for it. The DEC file or dictionary of messages that come off this thing are well known at this point, and somebody can make it happen. My concern's always been like, oh, can I do this and make some money off of it somehow, so that this isn't just a hobby for me, but actually pays for my EV habits. So far, nothing's come through, but.
Yeah, well, you got to come up with some classes on how to do all this. I mean, it's pretty cool what you've achieved. I think it would be a good thing. Or some sort of device that fits on your dash and kind of takes care of it for you.
Right. Well, if I can come up with, I'll come up with the Hyper 9 version and then the UQM version.
Yeah.
So I wanted to,
all right.
in the CAN stuff, I wanted to like stitch it all together now. How did this data get?
Go ahead. Yeah.
How did the data get to the screen of my in my garage, and how does it get to my phone app, which I have for the Humbug, so I can watch my cell voltages while I'm driving? I have a Android app that I wrote that is my speedometer, current gauge, battery monitor, fault watcher, etc. But it's all getting data in the same way, which is another protocol commonly used with IoT or Internet of Things devices called MQTT. So all the data that I'm gathering over CAN, I'm also broadcasting over the Wi-Fi network coming from the Humbug to whatever is around to listen to it. Sometimes it's my phone and sometimes it's the computer in my garage. So it's receiving these messages, which you see scrolling by on my screen right now, and showing the display in a more graphical fashion here on the screen. And
I
all
like it.
Thanks. And this is a little bit hard to read, but the one with the red on top, this is a green bar graph with red on top. That's the highest, and the green bar graph with the blue on top, that's my lowest. And I could see at a glance my highest and lowest battery cells.
Yeah, it's impressive, and I like how you brought it home. That's how we started with that display, and it's kind of fun. I've been over there to Kev's garage. You pull in, and all of a sudden the car starts talking to a display he has in the garage. So it's kind of fun. Like, imagine you've got this DIY project that when you pull in, you get a display, and you've got it here, plus you got it in the garage. So it's nice because you can kind of do some thinking about what cells are doing what, and then you won't be surprised.
Yeah. One of my next progressions in all of this is once you pull in your garage, it should show you a graph with a map of your latest trip, and it shows you how far you went on your range and where your hottest spot of your battery was and which cells dipped the lowest. It should just automatically pop onto the screen that's mounted in my garage.
Hey, that would be a cool feature. I got to tell you, the energy use is very, if it's got a good graphic, it's very useful. So I'll give you an example. I was driving across the country with the Tesla, and my range was getting bad because we were getting a headwind of like 15 miles an hour. Plus, I was doing about 80 miles an hour because we're in the middle of nowhere. And, so it gives you a recommendation. It says, hey, you're not going to make your destination. We're going to have to change your supercharger location. But if you just dial it back a little, if you went a little slower, everything will be fine. And literally crank it down. I think I cranked it down to 68 or 67 or something like that. And then boom, my range stabilized, and actually I gained a few, and I was able to get to where I wanted. So, sure, you're going a little bit slower, but it's not a big deal. You're trying to get to where you're going. So if you know the data and you can interpret the data, you can do something with it, like go a longer trip or find out a battery that's hot, learn about your car. So it's pretty cool.
Yeah, and in my case, it would be like, Tesla's already trained their algorithms to be this smart. So the car will recommend to you as you're driving, slow down if you want to make it to the next supercharger. They did that by gathering data just like I am right now and figuring out how their batteries and how their car behaves.
Pretty cool. We got Tom figured out how to turn on his microphone. How you doing, Tom?
Hey, there's
Yeah, I'm doing good, and I'm really soaking this up, and especially in my mind, trying to apply it to our EV Learning Center. And, the bus was always meant to be an educational tool, just like Mark's training table. And I don't feel like we're done fiddling with it by any means. And this is how we're going to, in my opinion, upgrade it so that it can continue to help people learn. The LC is still in its infancy. We still have not achieved financial viability into the, we don't even know if we could make it through the year. But the year is new. So, and one of the things we're working on is writing some more grants and doing some more education. And between the LC itself and devices such as the training table and this gadgetry of which Kevin speaks, and the bus itself, I feel like we can bring our educational endeavors forward. I'm really blown away by the fact that this Tuesday night thing has turned into such a valuable means by which we can share information and educate each other. I just want, and when I saw members of our cohort here, I'm just so enthusiastic about. First of all, we need to upgrade the bus. It's not safe. It is eventually going to be registered in California. It is eventually going to be the training mechanism for a lot of us. I want to tell you guys that I'm on board with carrying the financial load of upgrading the bus. even if I'm incapable of doing any of the hands-on. But I see that there are people here. I'm looking at their faces, and I'm really enthusiastic about this. So I can't thank you guys enough. Yeah, I see you, Talik. And I love you.
The work coding this Arduino software. All right.
All right, this is very cool. So,
And,
Tom,
we can move this forward. Unfortunately, I got a hard stop. I'm already going to get in trouble with the family.
No, we're going to wrap this up. Kevin, there's something else you wanted to add?
Well, I just wanted to, and I'm showing the data now as I showed on the Humbug. Now I'm showing it that's coming from this little ESP32 little round display device, which is 0 because it's not hooked up to any kind of car right now. But since the data is exactly the same, I was able to make the display exactly the same. It's coming from 2 different places. So I abstracted away the CAN data, which is different between the cars, and showing it in one common place. And all this source code will make available through the links to this video. If you want to see the code on how I did it on the ESP32, and I'll try to share the code from the Raspberry Pi version 2. I can do that here.
And is that round display on the torque? Is that right?
That's where it's supposed to be, but since the torque's out in the rain right now, I brought it inside because I'm doing more work on it. So, but yeah, the idea is that when I sell this car, I'll sell it with one of these little displays, which will handle all of the watching the charger as well as watching the batteries.
Nice. So, we're going to start wrapping this up. Omar, what do you got? Oh, you got to unmute yourself. Sorry.
Okay. All right, Kevin and guys, has anyone tried using AI to write programs?
That was a good question.
Well, so the reason I did that, I was using AI as I was listening to look up things you guys were talking about. So.
Oh wow, that's actually a pretty cool idea. Imagine you type it into ChatGPT or whatever. Explain in high school terms, college terms. You could ask it for different audience levels. That's actually pretty cool. It's a learning. It's an assistive listening device. I didn't think about that one. Because I don't know if yeah, go ahead.
It would complement nothing, in my opinion, needs actually hands-on training, but the academic part can be broken down in different ways through
That's great what you're doing, Omar. Just so I don't know if you guys know, I'm in the school system. I got to tell you, the school system's panicking. They are banning ChatGPT and asking kids to write handwritten pencil and paper reports. This is not going to last. This would be like trying to hold back a tsunami. Give me a break here.
It'll write you papers and it'll say, write this in the voice of a high school student.
Yeah.
So
this
smart.
Yeah, don't fight it,
I wonder if it could actually help write programs.
Yeah.
Save you a little bit of time.
No, it absolutely does. I haven't used it yet. What do you think, Kev?
Yeah, I've heard that it can, but I've never tried it. I think it can probably do some basic things, and you tell it, write me an Android program that will display basic MQTT information in this format. Maybe it could. It's going to require some back and forth, and it'll at least give you something to get started on and then move from there. So I do the same thing with Stack Overflow. I find I don't know if you use the website, but it's great for saying, I'm trying to read a database in these fields and do this. And somebody, chances are, has asked the same question. You can copy and paste their code and adjust it and fix it for what you're needing to do. So I'm relying on the intelligence of idiots all over the internet instead of artificial intelligence.
Well, I want to wrap
start
it up
somewhere.
Yeah. I want to wrap it up. I think this was a great night, and it's similar to the other nights where it gets really interesting right at the end, and you're like, oh my God, we need 2 more hours. But everybody spent time sitting their butts and learning. So I think it's really good. We're collaborating. We're going to come up with a new episode for next week. And Tog's going to help take a clip out of this, and we're going to pull it out, put it on the internet, something valuable. Thanks for coming in. Kevin, appreciate you going through this whole presentation. Mark, thanks for coming in. Cool. Always you have your perspective. Omar, I'm glad to hear that you got rid of your projects. I had to do the same. It's painful, but at least you focus on one project instead of 20.
Yeah,
Richard, Richard, thanks for coming in. It was like Mr. Wizard's class in his room. And Tom coming in from wherever he is in the world. Jonathan Knight's working on something good, and Talik, of course. So thanks a lot, everybody. We're gonna end the recording there. Anything anyone wants to add before we go?
Just a reminder, everybody, especially those that joined in later, the Out of Spec Renew is now live. The new channel on EV conversion focus, as well as reusing batteries, is now live. So give it a follow, and hopefully soon you'll see some content from me up there.
Can you repeat that?
Renew.
Spec Renew. If everybody's still looking at my screen, it's on YouTube. Yep. There is a YouTube channel.
Hit that subscribe button, Kevin.
I do that. Hey, I need to subscribe for everybody out there too. So.
Nice. Also, don't forget, maybe Jonathan would be interested. There's a battery class coming up. Lou's teaching it over at the EVLC. Just a reminder.
This Saturday.
Yeah.
All right.
Omar's volunteering, and I think Doug from the EV Riders is also volunteering there. So
nice.
And we're all gonna hop on your Mr. G's YouTube site and like and subscribe too if we haven't.
That would be awesome.
And share. Don't forget to share it. We need more people to see it.
Nice.
All right. Thanks.
Okay.
Thanks,
all right. We're going to end the recording there. Thanks a lot, everybody. And we'll see you guys next week.
Thank you.
Thanks a lot.
Sure.